All right, thanks, Ryan. You can hear me okay?
Yes, we can hear you.
Okay, just have to double check. So morning, I think it's still morning everywhere, to everyone on this call. If you're seeing this and thinking, I have a small airport or just small airports, my TAFs don't matter, please don't ignore this presentation because actually you're some of the people we want to talk to about TAFs. So we want to share some of the things we've learned working at the CWSUs and how like the big aviation picture all works. So this is a collaboration between the CWSU MICs in Indianapolis, Chicago, and Kansas City. So Mindy, myself, and Jen. And we're just going to jump into it here. I remember how to use a computer. There we go. So a little background. The why for this is from the Central Region Roadmap and the Weather Service PMO Evolve. So from the roadmap, initiatives were to identify DSS and messaging opportunities, establish a baseline of DSS, and then go from passive to active partner engagement. Then looking at PMO Evolve, that goal was to share best practices so we can have more common national IDSS solutions. So that's exactly what we're trying to do here when it comes to aviation. There was a CWSU MIC who once did a study, and I believe he said it was either 85 WFOs or 85% of the WFOs, so a large number, have no interaction with a Core 30 airport or a CWSU. If you don't know what a Core 30 airport is, we'll get to that. But we want to do a little background on the CWSUs just so everyone understands what we do. There's one CWSU in each of the 21 air traffic control centers. Those started in 1979 after a 1977 air crash that happened in Georgia, is pictured here. So I'll change that though to show you where all the centers are located. We have 2 shifts a day, so 16 hours per day of daily operations for 4 staff, an MIC and 3 meteorologists. And here in Central Region, we're actually kind of unique. There's a plan, and it's going to be rolled out again to have augmented staff at the CWSUs. We have a couple cross-trained forecasters from the forecast office. At the CWSU, we provide DSS to the FAA for both the regional airspace and the underlying terminals. That comes in a bunch of different forms. One is a recorded weather briefing called the pre-duty weather briefing. That's updated 3 times a day, and every operational controller within the airspace, so it's not just the control center, it's every tower within the airspace has to view that briefing before taking position every single day. We also do scheduled and on-demand verbal briefings, provide seasonal weather training, give written forecasts, things like that. We collaborate with AWC, the FAA Command Center, and the meteorologists at the Command Center, and of course the forecast offices. A couple collaboration products are our collaborative convective forecast called TCF, and then of course collaborating on TAFs. I'll use a soundbite from the forecaster who's cross-trained from the Romeoville Forecast Office, then here at ZAU, and he says doing CWSU operations is basically constant mesoscale analysis with some DSS. So you're studying the weather and going to brief. And last summer, Louis himself said that CWSUs were basically just like IMETs, of you're constantly looking at the weather and then providing briefings. The other piece of the aviation puzzle, of course, is the forecast office. So for you guys, your kingdom is the TAF and aviation discussions. We want you to start thinking of both of those pieces as the new version of, or the aviation version of the DSS packet. So how are we messaging to the aviation world what we're expecting at the terminals through the TAF and the aviation discussion? Your partners, of course, are the CWSU if you work with one, airport towers and TRACONs, and then airport operations such as snow removal operations. I'm pretty sure all of you are familiar with the coded TAF. You write them every single day. Part of that pre-duty weather briefing I mentioned is now a requirement that the CWSU show a handful of underlying facility TAFs. And Ryan down in Kansas City Center made this pretty awesome Excel spreadsheet that takes in the TAFs and puts them in this hourly gridded format so it's easier for the partner to read. So we highlight, I think here at Chicago Center, we do about 16 TAFs across CAU in our pre-duty weather briefing. And again, every operational controller has to view that, so they are seeing these TAFs every single day. Ryan's script also highlights impactful weather, whether it's low ceilings or visibility, precipitation, and gusty winds. Staying on the TAF theme here, we have 136 TAF sites within Central Region. We have 6 Core 30 airports. Core 30 airports are basically the busiest 30 airports within the US. So for Central Region, we have Denver, Detroit, Midway, Minneapolis, and O'Hare. And then O'Hare and Denver are actually 2 of the top 5 busiest US airports. Across Central Region, if you look at the top 200 airports, we've got 33 of them. And we also have some of the busiest airports when it comes to passenger traffic and cargo traffic. So I don't know if you guys have ever thought about, you have your TAF sites, but what about the sites that have some sort of general aviation operations but don't get a TAF? I mean, when I drive home, I see an actual runway in the middle of a field, and I've seen a plane land on it. That, of course, doesn't get a TAF, but that person needs to get information. A more applicable example is, so for Chicago, they do TAFs for O'Hare, Midway, and DuPage. Kind of situated in between them is Milwaukee Airport. Milwaukee does not get a TAF. They usually use O'Hare's. And we had their ground crew, their snow removal crew, reach out to us because they actually get awards almost every year for how well they remove snow at Milwaukee. But they were using O'Hare's TAF to make decisions, and sometimes when we changed the TAF, they didn't understand, they had to better understand how it impacted their operation. So it was a good opportunity to go out and meet with them and have a discussion about, okay, how are you using the TAF? Let's talk about the other forecast and come to a good conclusion and do some DSS with that. Some TAF rules. So we've got Directive 10-813. For a 24-hour TAF, shouldn't exceed 6 lines, excluding a tempo. And if you do a 30-hour TAF, that's 8 lines. If you want to be aware of operationally significant weather for the airport, we'll go over that a little bit more on the next slide. Be aware of amendment criteria, which may be more than just the traditional CAP criteria. You want the most amount of detail in the first 12 hours of your TAF. This matches what you guys are doing with the grids. The most detail you put is in the first 12 to 24 hours. It's the same thing we're asking for in the TAF. Vicinity, that is a hot topic across all of aviation land because no one uses it consistently. That's through us, the airlines, the FAA, across the board. So what we can control as far as the Weather Service is the rule in the TAF is it's 50% or higher confidence in whatever that vicinity is occurring within the 5 to 10 mile donut of the airport. So it's not easy, trust us, we know, but that's what the rule is, and we want to try to have some consistency when we forecast it. We'll get more into vicinity in a little bit. Tempo groups, as you know, are not to exceed 4 hours. Prop 30 groups are not to, or 6 hours or less, and cannot be used in the first 9 hours of the TAF. So when I say operationally significant, that could be things that really aren't always that obvious. Is there a crosswind issue? Lightning near the airport? Dense fog that's going to reduce RVRs or runway visibilities? Are there winds that impact their airport configurations that you need to be aware of? Is there an event coming in? Of course, in Central Region, we've got Oshkosh, we had the eclipse. I'll pick on South Bend, Indiana. Every time Notre Dame has a home game, or even Green Bay, when the Packers are in town, they see a lot of traffic. And then we already talked about snow removal. So you want to build a relationship with the airport and with the tower to try to understand these things. And then you're adding that DSS like you would to any other partner, even an emergency manager, into your product, the TAF. So heavy traffic times, runway configurations, any lower wind thresholds, again, that are more than just or different from the traditional VFR, MVFR, et cetera, categories. So example here is O'Hare, and this is just a portion of O'Hare Airport shown here. O'Hare has mainly east-west runways, so east and west winds are a friend, but the tower will call the forecast office and say, is that wind going to be a 360 or a 010? Is it going to be 9 or 10 knots? Sometimes it's 8 or 9 knots. That 10-degree difference or 1 knot difference can lead to refusals at the airport, and they have to, what we call, turn the airport around or change the complete configuration. That's a 20-minute process, and if they're in a peak of arrivals coming, everyone gets thrown into a hold, and now you've got a ton of delays that trickle down through the system. So we try to get the timing nailed as much as we can. So it's, you start maybe the day before with putting in, okay, a lake breeze is about this time, and just like anything else, as it gets closer, you refine it to get the best time possible. So the FAA can use that to try and plan, okay, we're preparing for the lake breeze at this time. This looks like a good time for us to flip the airport around. We're going to do it. To facilitate that and other winds, Rob Kazmarek here at ZAU created this compass that helps us understand how the winds impact O'Hare. So again, it's an east-west airport. So east-west winds are great pretty much at any magnitude. When you start getting to adding more of a northerly or southerly component, you start to have impacts. The forecast office and the CWSU both have a copy of this, so we know when we're getting close to thresholds. We can pay attention to, is it going to be within that 10 or 20 degree range, and what are the sustain or gust thresholds going to be that are going to impact O'Hare. This is just a way that we've learned the partner and are applying it to operations like we do for any other partner. Low level wind shear is another one which maybe we don't really think much about, but if you do have a smaller airport, you're going to have smaller planes flying into it, and they're much more susceptible to low level wind shear. So when you're looking for low level wind shear, you want to look for, of course, speed and direction changes in wind in the 200-foot layer between the surface and 2,000 feet. And for the TAF criteria, you usually mention it with 30 knots or more, but some sites may have a lower threshold. When pilots issue a report or a PIREP, the minimum criteria for an urgent PIREP is plus or minus 10 knots of low-level wind shear. And AirMet for low-level wind shear is issued at plus or minus 20 knots. So that's a conversation perhaps to have with the airport of what level of low-level wind shear do they have. They may not know, but it's a conversation to have, and you might be able to incorporate it into your TAF, adding extra DSS. Again, if you're thinking, yeah, but still it's a small airport, really doesn't matter in the grand scheme of things. Yes, it does. In fact, I went and double checked with the controllers this morning to ask them for other ways that the smaller airports matter in the big picture. And of course, small planes go to bigger airports. When they take off the ground, they still have to fit into the mess you see on the screen here that is the national aviation system as everyone moves around, and I'll play here in a second. But again, focusing on O'Hare, if there's weather expected at O'Hare, every single plane has to declare an alternate in case something happens. Those alternates can range from Rockford, Illinois, Milwaukee or Madison, Wisconsin, Kalamazoo, Grand Rapids, Michigan, Indianapolis, Gary, Indiana. So even if you think those sites don't matter, they may to a plane that needs an alternate place to land. So just a quick picture here so you can see how busy things can get. This is just for Kansas City Center. The red dots are going to O'Hare. The dark blue dots are going to Dallas-Fort Worth. The cyan or light blue colors just other traffic moving across Kansas City Center, and the green's going to Denver. So when these planes take off, they've got to fit into this big picture, which has a bunch of different forecasts going on, the TAFs, and then the greater picture as well. There we go. So speaking of Kansas City Center, in January 2020, they did a survey to the aviation partners, got 240 responses, a mixture of airlines and air cargo, business jets, and general aviation. One question was, I must declare an alternate and fuel for that alternate if the following occur. Thunder by far had the biggest impact, excuse me, and had more impact on airlines than any other weather phenomenon. You can see for prevailing thunder, over a third said that they would declare an alternate and have to carry alternate fuel. Interestingly enough, vicinity thunder was a little bit lower, but still had an impact. We try to put that to numbers. From Southwest Airlines, you can see for VFR, if they have to plan on average for extra fuel, it's just under 7,000 pounds. But for vicinity thunder and prevailing thunder, there's really only a 1,000-pound difference between 11 and 12,000 pounds. When you put that in dollar amounts per flight, there's only a $150 difference between vicinity thunder and prevailing thunder. So per flight, the airline's going to have to add on $3,500 on average to $3,650 for prevailing thunder. It's not much of a difference. On the right then is a video just showing air traffic trying to get into the East Coast when there's thunder going on. But the bottom line here is that vicinity does cost them about as much money as prevailing thunder does. So sticking on the fuel topic, when are they making these decisions if they need to declare an alternate or add extra fuel? Typically, it's about 1 to 2 hours before takeoff. But if you've got a flight going from the West Coast to East Coast, you're looking at about 2 to 3 hours before the flight takes off. So all said and done, the first 5 to 6 hours of your TAF are a critical period. I remember working midnights at Chicago and having Southwest call me at the end of a midnight shift saying, we're trying to get planes off the West Coast. Can we talk about the TAF? So they're looking and they're trying to plan ahead. When it comes to business jets and the GA community, when they asked respond with other. It was either they make the decision before takeoff or 24 to 40 hours before flight. More than 50% agreed it's within the first 6 hours of the TAF that they're looking at. As far as freight operations go, we're going to look at Louisville, Kentucky, which has a lot of freight operations. So the graph at the top here is just the arrival rate coming into Louisville. You can see 1516Z, they've got less than 20 planes per hour coming in. Traffic drops off until the overnight time. We see a spike in UPS traffic at 2, 3, 4Z through 6Z, where they're getting over 40 planes per hour. That's basically all UPS traffic. So they usually have 150 arrivals on weekdays, and that peaks to about 300 near holidays. So if there's a change to the TAF or something happens at the airport, they have to work this in just like they would with passenger traffic. But now you're adding delays to the commerce side of aviation world, where they have to there could be delays in planes arriving, and then just a few hours after they arrive, they're emptied, restocked, and sent out again, just like with passengers. So any changes could lead to delays in all this and add fuel costs. So we're still going to pick on vicinity because it's an area where we can see some improvement across the board. If you've ever thought, well, I'm just going to put in vicinity thunder for 12 hours just because I'm not sure if they're going to get hit, and that's just going to be my best option. It really isn't. We already went over how much it costs the airlines, but try to remember, if you don't have 50% confidence in incurring, leave it out. And again, we're trying to stick to that 5 to 10 mile donut around the airport, which again is difficult. So if you're not sure about 50% criteria, take a look at your POPs, take a look at what you're putting in for Prob TS or your thunder chances. If it's not 50%, don't put it in the TAF. Throw it in the AFD, talk about it, maybe wait and see how things evolve. But as your forecast, you're updating your forecast, you're looking at the environment. Okay, when am I expecting thunderstorms to develop? Is it going to be isolated or scattered? What type of thunderstorm? As you put that detail into the grids, amend your TAFs to match. And again, include all this in the AFD, any of your uncertainty or certainty trends, what you're thinking, because the partners do read the AFDs. I always wondered as I wrote the aviation AFD of who is actually reading this, but on AWC's webpage, the AFD page is one of the top 10 most popular pages. It had 4.5 million views in 2019, which was up from 2018. The average time spent viewing is about 10 minutes, and it doesn't matter what season it is, it's about the same. So back to Kansas City Center survey, 33% of respondents said they used it regularly, and then just under 80% said they used it sometimes. But it is a way to communicate what we can't communicate in the TAF because of the TAF rules. So we also have to look at the different perspectives. So from a forecaster perspective, you've got the point forecast, and then if you use vicinity, you've got the donut forecast. So you got two things going on here. So also try to think of it like a spot forecast. It's just another form of DSS. Aviation users, though, are concerned with a much larger area. We talked about them having to look at alternates and look at what else is going around. So they're shopping for forecasts, just like any other partner does when we do DSS. So they're looking at multiple TAF sites. They're looking for consistency. I've taken calls I worked at the forecast office from O'Hare saying, your TAF says the lake breeze is coming at this time, but your hourly forecast graph has it 2 hours later. Which one is it? That's a wake-up call. You want to have everything be consistent, so no matter where they look or who they're getting a briefing from, it's the same message. So forecast consistency is key. So just going over some of the things we talked about here, things you want to know is airport traffic times, when they have peak operations, what types of aircraft are landing there, do they have unique thresholds you need to be aware of, what are the runway setups? And I can go back when we go to questions. There's a website you can look at to look at the different configurations of the airports in case you want to look at winds for that. When you get those thresholds, use them when you forecast in the TAF, and then make sure your grids and your TAF are consistent, and then you're also communicating through the AFD, preferably in plain language. So can we do more DSS with aviation? Absolutely. We can do a lot more partner engagement. I know in the Chicago Center, we've talked to the aviation focal points at the forecast offices about wanting to work together on some outreach so we can somehow split the load. So we're learning more about our partners. When it comes to severe weather operations, consider if there's, like with the derecho that came through, giving some of the towers a heads up, because I think the last place you want to be in a derecho is up in a tower. Give them a heads up so they can evacuate, and some of the recommendations reflect that in the latest after action report. So try to stick to the 6-line limit. I mean, we all know the practically perfect TAF, so do the best you can. But that first 6 hours and even are the most critical time for the FA to make good decisions. You want to help them set them up for success and make sure they're understanding what you're expecting. The most effort and detail should go there. No more than 4 hours for a tempo. And again, amend. When you're publishing your grids, take a look at the TAF and make sure that it matches. Be aware of any operationally significant thresholds. We talked about consistency. And there's one thing you take away from this. Please let it be a 12-hour window of vicinity thunder is not helping aviation land. Limit vicinity to as much as possible, and stick to, if you're not 50% confident it's going to hit that 5 to 10 mile donut, don't put vicinity in. And so with that, I'll go back a slide and I can take questions, Ryan.